Hello, this is P. Roshni from EC Department. A presentation on Indian Regional Navigation Satellite System. Coming to the history of satellites, the world's first artificial satellite is the Sputnik was launched in 1957, and the first satellite that was used for the communication purpose in India was Aryabhatta. On 19 April 1975 they was launched. The first geostationary communication satellite was nicknamed 3 on 19 August 1963. And the father of geostationary communication satellites is Harald Rosen. He was the aircraft engineer on the geostationary communication satellites. These are the components of the satellites: the solar panel, propellant tanks, and the star sensor. Solar panels, or the both sides are connected with the solar panels, and the lift-kit upper motors, and the global horn, and in the corner cube retro reflector and C-band harness. Like many of these are the components of the satellite systems. Anyone thinks that how the satellite works? Really, a Earth station sends a message in GH range, whereas an uplink are a translating Earth station, and the receive Earth stations are on the Earth or belongs to the Earth stations. The satellite receives a transmit signals and retranslate the back to the downlink. And the difference between the downlink and the uplink, that the frequencies is 2 GHz, are at the local oscillators and the mixer at the low noise amplifier and the power amplifier connected to the input frequencies and the output frequencies to go to the satellite. Coming to the India's own regional navigation satellite system is a NAVI, the introduction part. And the Indian Regional Navigation Satellite System is the own navigation system from India. It is also called as a NAVIC, used in the operational name. And the total launches has been taken to the by India is 9. Its first launch on a 1st July 2013 and the last launch on 12 April 2009. But in the status, the operational, it is going on. It is operated by the ISRO, Indian Space Research Organization. The total orbital height is 36,000 kilometers, where satellites in orbit is 8. Coming to the satellites, there was launch of the 7 satellites. The first 7 navigation satellites in India were the Regional Navigation Satellite System series of satellites to be placed in a geosynchronous orbit. It was built at a ISRO Satellite Center, Bangalore. At the cost of 125 crores of the US billions of 19 millions, it was lift off a mass of 1,380 kgs. The satellites at the second IRNSS IB. It was placed in a geosynchronous orbit on 4th April 2014 at the PSLV C-24 rocket, Satish Dhawan Space Center, Sriharikota, where at the satellite weighs is 1,432 kgs for tracking the map services. They were launched two successfully satellites to the orbit. They have launched the 4 deployed satellites at a time, the IA, IB, IC, and ID. They have idea to launch it to IRNS E is planned and launched successfully. And F and G by the March of 2016 they have launched to the orbit, and the fifth satellite was launched on 28th January 2016 using India's PSLV C-31. Coming to the end of the satellites they were launched, IRSS IG is the seventh IRS satellite. It was launched on 28th April 2016 using India's PSLV C-33, which concludes the setting up of Indian Regional Navigation Satellite System. There are two types of IRNS, that namely Standard Positioning Service (SPS) and the Restricted Service (RS), where the IRNS have 7 satellites out of 4 are already placed in orbit. The fully developed IRNS system consists of 3 satellites in geo orbit and the fourth satellite in GSO orbit consists of 36,000 kilometers to the Earth's surface in the orbit stations, with 3 geostationary, 4 geosynchronous, and orbit altitude 36,000 kilometers. The cost of 1,420 crores were covered by the India and up to 1,500 kilometers behind its border from the satellites of the fourth satellite is the geochronon orbit in a phase of move in a two include orbits where three satellites or geostationary orbits appears from the ground to the fixed level in the satellite. What is geostationary and geosynchronous orbit? At the geosynchronous orbits, an orbit around Earth whose orbital period is equal to the sidereal time. Sidereal ray is at 23 hours and 56 minutes irrespective of its inclination, that is a title with a respective of pulse. Example, a person on a point on Earth will see the satellite in this orbit in the same place in the Earth in the sky at the same time of the day. It contains with every day of satellite system. Geostationary satellites, a second orbit around Earth at 35,786 kilometers above. It remains stationary above a fixed point on the equator. It's always in the same place on the Earth and consists of view from the Earth. Example, a person on any point on the Earth will see a satellite in the orbit stationary with respect to its position. It contains with a position where the geosynchronous Earth consists with a point on Earth, and just like a star in the sky, it rotates combined to the Earth. These are the axis of rotation combined with the geosynchronous orbit and the geostationary orbits. IRNSS elements are based on three segments: space segment, ground segment, user segment. Space segments consist of seven satellites, with three satellites in a geostationary orbit and the four remaining satellites are in geosynchronous orbits. The covers longitude crossing to the east. The satellites are specially configured for the navigation purpose. IRNSS satellites are to be launched by the Indian launcher, the PSL. These are the space segments where covers the 1A orbits and the IC orbits, ID orbits, IB and IE. Total longitude to the east where contains ground segments. The Spacecraft Control Station Center (ISSC) will manage the maintenance of satellite constellations and command telemetry, and the command stations were receiving telemetry from the IRS constellations, uplinking navigation updates with CDMA. A ranging of stations facilitate accurate ranging of IRN satellites and send the data to the navigation control centers with by the ground segment. User segment. The user segment consists of specially designed dual frequency receiver. The several types of receiver are planned for dual frequency reception. The capability of receive ionospheric corrections. The user receiver may receive other constellation in addition to the IRNSS. The all seven IRNS satellites will be continuously tracked by the user receiver. The user receiver will be a minimum and the similar GPS user receiver. And the IRS chat architecture, the space segments consist of components of the space user control, the user segment and the ground segment. IRNS configuration that consists of user, space, ground, and connected to each other. The spacecraft central center and timing centers, ranging the stations, lands, ranging stations, irons, navigation centers, data communication centers that totally connected to the configurations. The coverage of position accuracy, the instead of services area for IRNSS is primarily the Indian land mass. The service area for the IRNSS is generally specified at between a longitude at the 40 degrees to the east latitude to the between the 40 degrees. Iron systems provides a dual frequency user that are targeted the position accuracy less than the 20 meters the coverage area. by the IRNS coverage. Here, the con- payload of a configuration of IRNS is connected to the ground levels of the frequencies in the generator's lens, and the Navi data uploaded to the satellites covered area. IRNS coverage, where IRNS coverage belongs to the 1,500 kilometers to the 2,000 kilometers around Indian landmass countries. Can uses the IRNS navigation system to the member of countries including the India, Afghanistan, Bangladesh, Bhutan, Maldives, Nepal, Pakistan, Sri Lanka, like more, where covers to total coverage by the IRNS system. Countries who have their own GPS trackers, where the GPS belongs to the US nation, and the GLONASS belongs to the Russia, and the Galileo belongs to the European Union, Beardian belongs to the China, where India depends upon the GPS, where it belongs to the US system, where before the we cannot consist of a own navigation system, but INNS where came and the India the first satellite launches on 2013. Lifetime of each satellite are 12 years, and the preciously 20 million for the civilians and the 10 millions are for the military. They were consisted of own GPS satellite system. Here, the comparison of IRNS and the GPS, where GPS are the first US government were launched. The orbital height is 20,000 kilometers. The range of covers entire globe. Coming to the IRNS, the own satellite system of India, the first launched on 2013 and owned by the government of India. They were launched at 7 satellites from now. The orbital height is 36,000 kilometers. The geostationary Earth orbit range of India or Indian landmass around Indian landmass that covers totally. IRS applications, terrestrial, aerial, and the marine navigations were tracked, disaster management, vehicle tracking, and the fleet management and the integration with the mobile phones, precious timing, aid for hikers and the travelers, the visuals and the voices navigation for the drivers were INS were usually developed in India. At the last conclusion part and the future prospects, the IRNS India has placed itself in a prestigious league of countries having their own satellite navigation system and as a provider metal and its advanced technology as huge developed to cover the areas entire the world. In future, the more satellites can be added to increase the cover so much. So the cover is entire globe just like a GPS system. That's all. It is useful topic, I think. So and thank you. Have a good day.